First, let me thank you for joining us on this birthday party, the 40th anniversary of the Tyler Prize for Environmental Achievement. Today we'll be briefly looking backwards on the environmental progress that has been made in those 40 years, but primarily looking forward as to what we should anticipate in the coming few years with an exciting panel who will lead, I'm sure, a very interesting and informative discussion for us. We have brought them to, these panelists today represent those of 67 individuals as well as 4 organizations who in the past 40 years have been awarded the Tyler Prize for Environmental Achievement. We're also delighted to have as our moderator today Dr. Rachel Maddow, who will, I'm sure, provide a lively and informative discussion for us here. If any of you have talking points, discussion topics, or questions you'd like to have the panel consider, if you have some cards that you want to write them down on and wave them around, we'll have people coming around and picking them up in the next few minutes. So if you have something there, that would be fine. If you would like to be a little more electronic, you can tweet these same inquiries to us by using the Twitter hashtag Tyler40, Tyler40. We'll get you in contact. We'll be looking at these as the panel proceeds, and if as time permits, pulling out, I'm sure there'll be many of them, pulling out some of these for further discussion by the panelists. Before we invite the panelists to come to the stage, we're going to take a few moments to look back at the first 40 years of the Tyler Prize. And at this time, we're going to be looking at a brief video that shows us what has been accomplished in these 40 years.
The Tyler Prize is a wonderful institution that recognizes the contribution that individuals have made to improving the environment. It's a tapestry, it's a myriad, it is a whole collection of disciplines, of people, of fields that make up a study of our environment.
It meant a lot to me. It was nice to have somebody looking over my shoulder and saying the work was good. That was great.
I was totally stunned, and I just couldn't believe that something this prestigious was being given in recognition of me and my work.
You just sit there with this giant grin on and say, wow, I'm here.
And people know that you are a Tyler Laureate. And that just makes it a little easier to start the next difficult conversation.
The end of the 1960s and the 1970s was the big movement and an awareness and awakening of the environmental situation. Mostly focused around obvious problems of pollution. Air pollution, water pollution at the time was something that the public could see and began to become aware of.
John Tyler was one of the founders of Farmers Insurance Company. Moved from the Midwest to Southern California. Now, I never met John Tyler, but I had numerous conversations with Alice Tyler, and the Tylers were very aware of environmental deterioration and endowed this prize to help to bring greater awareness and to look for means to alleviate that deterioration.
The very first Tyler Prize award ceremony was actually presented then by Governor Ronald Reagan. So there was apparently some interest in California at the level of the governorship in terms of the environmental problems of the time.
Alice Tyler was the moving force for this prize. During the time when she was alive, she was very much part of everything that we did. So we were always blown away by the movie stars coming into the room, whether it was Lloyd Bridges, Art Linklater, Jimmy Stewart, Betty White, or many others.
So they became interested in what we were doing. They were friends of Alice, but they also had a personal interest in various aspects of environmental quality.
So at that time, there were many prizes, but this was one of the first prizes to be given in the area of the environment. The Tyler Prize not only brought attention to environmental deterioration, but it stimulated scientists to do environmental research to show the causes, but also means to alleviate the problem. I think that over the years, we've become broader. The original prize was for environmental deterioration. We were thinking of rivers, lakes, and the air. Slowly, it became more global. We began to think outside the United States. The committee became more aware that extinctions were occurring, biodiversity was getting threatened, and that habitats were disappearing. And we needed to give prizes to individuals who were working in these areas. So when we're thinking about conservation, we then begin to think about resource management. You naturally are led into energy, food, and water.
Climate and energy is a big combined field because you have many aspects coming in at this that ties work from the very early years of the Tyler Prize up to today.
And the issue of climate change now becomes a global issue. We see the Tyler Prize over the last few years becoming aware of environmental health and asking the question, who are the key players in keeping environmental health on the forefront of science and policy?
When I got the telephone call about the prize, I was sitting at my desk at home, and right there is John Seinfeld's great big book, you know, the classic textbook on air pollution. So, you know, that was just an honor by itself to be in the same people's thought as John Seinfeld.
Well, past Tyler Laureates really are in many ways responsible for my entire career. My particular interest in plant-insect interactions was inspired by a paper written by two laureates, Paul Ehrlich and Peter Raven, and of course Edward O. Wilson. So they're all people who have just had profound influence on how I view the world.
So to be given a prize in the tradition of G. Evelyn Hutchinson, Rene Dubose, Charles Elton, meant a lot to me. And I have to say, I admire people who have gotten the prize after me as well.
It just says that collectively what you've done up to that point has been really important, and it actually gives you an assist in being able to do more once you've been so recognized.
The future is difficult to predict, of course, but we know one thing is inevitable. The world population will continue to grow.
The same sorts of environmental challenges that were faced in the 70s, we have not solved these problems. I mean, we have some solutions, but then again, as technology advances, we create new problems and new challenges.
Everybody has his or her standard list: air, water, climate change. One very major environmental challenge that is not getting any attention at all, and that is the environmental challenges of increasing urbanization.
The issue is how to take these things on at the scale and urgency they deserve. We have to redefine what we consider the quality of life. And you can't have quality of life without a healthy environment.
I think the value of the Tyler Prize is to remind us that the environmental issues aren't just about political debate. They're not about ideology. The environmental issues really trace down to very basic scientific processes. We need people who will help us to understand them and spend their life long doing this. So it's a very good thing to recognize these people. It's a good thing to say thank you for what you've done, but it's also a good thing to give us something to listen to so that we can maybe start to make our own world a little better.
In those 40 years, since we started this 40 years ago, we checked recently, and there are now globally over 1,000 awards and prizes in various aspects of the environment that are being given. We've been with this a long time, but certainly the world is changing and the world is recognizing the importance of the environment in which we live. With that background, we now want to take a moment to recognize this year's the 2013 Tyler Laureate, Dr. Diana Wall. Dr. Wall is recognized for her accomplishments, contributing to our better understanding of the structure and function of that very often overlooked and often ignored, but totally and completely vitally important ecosystem we call the soil. The stuff we walk on, but the stuff that our livelihood depends upon. Dr. Wall, will you please stand and be recognized? We also have in our audience, in addition to our panel, the 4 laureates, we have one other Tyler Laureate who has joined us today, Laureate Stuart Pym. Would you stand and be recognized, Stuart? As you may have gained from the video, the Tyler Prize is awarded by an executive committee, an international group of people coming together to evaluate a great number of nominations and finally select people who deserve this extraordinary recognition, such as Dr. Wall. I'd like to have the Tyler Executive Committee stand together and be recognized. Actually, they are your hosts for this noon gathering. And now for the commercial. As of the award last evening, the 2014 call for nominations for the Tyler Prize is now open. That nomination call will be open until September 13th, and I would encourage you to strongly consider offering up individuals whom you know, or organizations for that matter, who are worthy of the recognition provided by this prize. You can get the full nomination information by going to the Tyler Prize website, and you'll have all the details, all the information, and all the forms there necessary. I encourage you to submit nominations for the 2014 award. Now, let's introduce our panel and our moderator for the day. You have a booklet that has extensive biographies of each of them in front of you. If we read that through all of those, we wouldn't have time for any discussion. So I'll leave it to you to read these in depth, but let me just briefly introduce them to you as we come across here. Dr. Richard Alley is professor of Pennsylvania State University, and he hosts PBS's Earth, the Operator's Manual. Dr. Alley received the Tyler Prize for his work in the study of the history of global climate change by his work on the changes in ice sheets and glaciers. Next to him is Dr. John Holdren, who is assistant to the President Obama for Science and Technology, director of the Office of Science and Technology Policy, and he's co-chair of the President's Council of Advisors on Science and Technology. Dr. Holdren received the Tyler Prize for his research and his leadership at the intersection of energy and the environment and our economic system. Our moderator for today, Dr. Rachel Maddow, MSNBC's host of The Rachel Maddow Show. She's author of the New York Times bestseller, Drift, The Unmooring of American Military Power, and she has received numerous recognitions and awards professionally, and these are all listed in the booklet there. She has provided excellent coverage of environmental issues that includes both science and policy and politics. Dr. Thomas Lovejoy is university professor at George Mason University, and he's chair of the Global Environment Facilities Scientific and Technical Advisory Panel. He was awarded the Tyler Prize for his pioneering work on the significance of biodiversity. And Dr. Mario Molina is director of the Mario Molina Center for Energy. He's a professor at the University of California at San Diego and also professor in the Center for Atmospheric Sciences at the Scripps Institution of Oceanography. Dr. Molina was recipient of the Tyler Prize and subsequently the Nobel Prize for chemistry on his work in ozone degradation. I'm happy now to turn the event over to our panel and our moderator, Dr. Maddow.
Thank you very much. My favorite part about that whole introduction was the pointed subsequently the Nobel Prize. So here's an idea to start with this morning. And the idea is quaaludes. Quaaludes used to be a thing, right? In the 70s, quaaludes were a very widely abused drug. By 1981, the DEA said the most used drug in the country was pot, but the second most used drug in the country was quaaludes. Quaalude abuse was on pace in those early 1980s to equal the severity of the heroin problem within just a couple of years. Now, there are two ways that you could get quaaludes if you wanted to get high on quaaludes. You could get the branded prescription pill, which was made by a single drug company, or you could cook them up illegally. But there is a reason that there is not a quaalude problem in the United States anymore, and it is that the basic compound that you need, the basic chemical compound that you need, which was first synthesized by Indian scientists in the 1950s, it's very hard to make. It's too hard to make in a sort of cook shop doper lab somewhere, even if you're sort of a good cook shop doper laboratory scientist. So in order to make the drug illegally, what the cartels would do is that they would have to, because they could not make the basic compound, they would have to purchase it. And so they would bulk purchase it from this small handful of professional large-scale factories who were making that compound legitimately. There were only 4 of them. Germany, Austria, Hungary, and China, 4 large-scale factories. We think of the drug war as mostly a futile enterprise, right? I mean, basically a worthy idea, but basically futile. If people want something and there is a lot of money to be made in getting that thing to them, we generally think that people are going to get it. But there is not a quaalude problem in the United States anymore. You can ask your druggy friends. They used to call quaaludes disco biscuits. Ask people who remember what a disco biscuit is. They will tell you they cannot get it anymore. It's also, I think, why there's no glam rock anymore. It was the only thing that made glam rock palatable. But what was on track to equal heroin in this country doesn't exist here anymore, and that's because it was beatable. There was only one legal manufacturer of the pills, and so at a policy level, we banned the legal sale of the drug and made sure that one manufacturer complied. In terms of the illegal sales, we convinced or bought off those 4 factories who made that complicated base level chemical compound. We convinced them or bought them off so that they should stop selling it in bulk. And so the US has no Quaalude problem anymore. Now people snort oxycodone instead. Whatever you think about the drug war, I wanted to raise this story this morning because I am a non-scientist. I'm a believer, which you have to say now. But I am a non-scientist. I cover news and politics and to a certain extent public opinion for a living. And as a non-scientist, I'm here to tell you, true believers all, that the general public in the United States thinks that the whole idea of human effort to combat climate change is futile. That the whole idea of environmental science is the complex and nuanced measurement of hopeless, slow-motion catastrophe. That basically you guys work to tell us the horrible consequences of our collective behavior, but we believe, broadly speaking, that changing our behavior now is not possible in any meaningful scale and also not going to make a difference anyway. In the mind of the general public, broadly speaking, the Earth is now the drug war. Worthy, maybe, but basically futile. So what are the Quaalude stories? What are the things that can be explained about achievement in environmental protection and environmental science that can help us all, even not the true believers, that can help us all understand that all of this distinguished work is not just about writing the chronicle of a death foretold? Along with Roe versus Wade and me and a lot of other beleaguered 40-year-old things, the Tyler Prize is 40 years old this year. The Tyler Prize was founded in an era that we can think of as the Cuyahoga River catching on fire era. The Cuyahoga River does not catch on fire anymore. But the last 15 years were the warmest since we started tracking our warmth instrumentally over 140 years ago. The pace at which we are pushing change in the climate appears to have surpassed any rate of change that we can measure in the last 10,000 years. Invasive species, biodiversity loss, climate change, habitat fragmentation, pollution, they're all occurring simultaneously, and they are interacting with one another in a way that attempts to ameliorate just one of them can alter or maybe even exacerbate the impacts of the others. So we have real challenges. But the Cuyahoga River doesn't catch fire anymore. And you can't get Quaaludes for love or money. We have 4 of the most esteemed laureates in the history of the Tyler Prize here today. And we are going to talk about the challenges that we face, but we are going to talk about it with also the idea of past progress, with what has been achieved, because change is possible, but the general public does not yet believe that. Today we herald the newest Tyler laureate, Dr. Walls, and right now we are going to hear from some of her predecessors. Dr. Richard Alley is going to talk about ice and climate change. Dr. John Holdren will address the energy challenge. Dr. Thomas Lovejoy will explain the race to save species and ecosystems. And Dr. Molina will discuss clean air and healthier populations and development prospects. And after all 4 of the laureates speak, we're going to have a little time for discussion in which I will try to elucidate the things I didn't understand about what they said. And then we'll take questions and comments that you all have contributed on paper, plus we have a connection to the internet machine through which people have contributed questions and comments via Twitter. But without further ado, Dr. Alley, you have the stage.
Thank you. We love the good things we get from energy, probably more than a glam rocker loved Quaaludes. I can virtually guarantee you that there is no one in this room who is planning to spend the entire summer hoeing corn so that you do not starve to death next winter, because you actually have a tractor doing it for you. But that tractor and everything else in our economy are primarily fossil fueled at this point. They don't have to be, but they are. And they release CO2 to the air at a rate that is something like 20 tons per each of you. 20 tons, 20 tons, 20 tons, 20 tons, 20 tons. In round numbers, that's the right number. Our concern about this is not because it's a large number, it's because of physics. It's physics we've known for more than a century. It is physics that really was worked out by the Air Force right after World War II. Now, they were not worried about global warming at that point. They were worried about what kind of sensor do I put on a heat-seeking missile so that I can see the heat from the enemy bomber, which is blocked by CO2 in the atmosphere in some wavelengths. And in some bizarre sense, if you deny the warming influence of CO2, you're denying that the Air Force knows what kind of sensor to put on a heat-seeking missile. Okay? Now, the Tyler Prize has been running long enough. Roger Revelle in '84 knew the basics. We've been running long enough that you can see the early predictions coming true. It happens, it works. The Air Force's physics are functional. I get to do history. I'm a climate historian. I do ice cores and other things. And I and a huge community of people who do this know that over 4 billion years, those physics work. And that CO2 has been primarily the biggest control knob getting the Earth's average temperature. It works. When we read history, though, we get something else. Sometimes our climate system is a little bit like a drunken human, possibly a human on Quaaludes. If you leave it alone, it sits there. And when you force it to move, it staggers. And we call those abrupt climate changes or ice sheet collapses or things like that, but it is possible that if you push hard enough on the climate system that you trigger something really big that we wouldn't like very much. Now, if you ignore that, you just take the most likely outcome for the future, you run it through the ecosystems and into the economies, it is very clear from immense solid scholarship that we are better off dealing with this for the economy than we are ignoring it. And if you put in national security and listen to the admiral, or you put in the golden rule, we're even better off dealing with this and ignoring it. Now, be very clear, this is science. There are uncertainties. It may be a little better than this, it may be a little worse. But we all know that building is harder than breaking. If you want to build a civilization, you want to build a city, you want to build a studio, it takes more than one tool. But you could break this building with a big hammer, with a wrecking ball. We see no way that cranking up 20 tons of CO2 per person per year can turn the Earth into Eden. That takes getting a lot more right than just CO2. But we do see the way that a big wrecking ball might trigger an abrupt climate change, might trigger an ice sheet collapse, might trigger something big that would really impact us. And so what we know says we're better off if we put this into our planning and use it to make wise decisions. What we don't know puts an exclamation point on that. It makes it all the stronger.
Dr. Holdren.
I like to frame the energy challenge this way. Without energy, there is no economy. Energy is the lifeblood of the economy. It is essential for job creation, for production, for growth, for income. Without climate, there is no environment. The climate is the envelope within which all other environmental conditions and processes on which we depend have to work. And if you wreck the climate, you wreck everything in the environment. And the challenge is that around the world, societies are getting the energy that their economies need in ways that are imperiling the climate that their environment needs. And that means that today in the world, even in 2013, over 80% of all of the world's energy supply is coming from the combustion of coal and oil and natural gas in ways that release all of the resulting carbon dioxide to the atmosphere. And as my colleague Richard Alley has just pointed out, that is the fundamental driver of the global climate change that we are experiencing. In the United States, over 85% of all of the energy we use is coming from burning fossil fuels. Now, in the context of this 40th anniversary, if we think back to 1973 and ask what is different about the energy picture globally and in the United States 40 years later in 2013, if we look at the global picture, The biggest thing that is different is scale. The global energy system and the global fossil fuel use is twice as big in 2013 as it was in 1973, twice as big, and the mix of energy sources has changed very little. Overwhelmingly, it was a fossil fuel-dominated world in 1973, and it remains a fossil fuel-dominated world in 2013. If you look at the United States, however, there is a piece of good news. The mix is still very similar to what it was in 1973, but the scale has only gone up about 26%. It hasn't doubled in the United States, it's gone up 26%, while the economy nearly tripled in that time period. And the good news in that is that we were able to reduce the amount of energy that it takes to generate a real dollar of GDP by more than a factor of 2 over this period. We are more than twice as efficient in the United States in getting the economic goods and services we want and need out of the energy supplied to the system. The next question is, where are we going in the next 40 years? What do we need to do in order to address this fundamental challenge of energy's dual role as essential to the economy but imperiling the climate? And I would argue that there is a two-pronged strategy which we need to put into place. Both prongs rely fundamentally on better and better technology. One of those prongs is to use better and better technology to further improve the efficiency of energy use. This is actually the fastest, cleanest, surest, cheapest way to reduce our greenhouse gas emissions, is to continue to reduce the total amount of energy that we need to generate the goods and services that societies want, and we can do that. We can double the efficiency of energy use in the United States again. We have an explicit goal from President Obama to do that by 2020, to double it again, and we can do it for the world. The second prong of the strategy is to use advanced technologies to make a transition from burning fossil fuels in ways that put all the carbon dioxide into the atmosphere to getting our energy in cleaner ways, which can be renewable energy, it can be nuclear energy, it can be fossil fuel technologies that capture and store the carbon dioxide rather than letting it into the atmosphere. It can be geothermal energy. But we have the technologies to do this, to do it safely, to get the energy we need in ways that release far, far less carbon dioxide to the atmosphere. And that, again, is one of the thrusts of our current policy in the Obama administration, and by the way, in many other countries around the world, to make this transition. We have doubled in the United States the amount of energy we get from solar energy and wind in the period since 2008, and we intend to double it again by 2020. So steadily increasing the fraction of energy we get in ways that don't imperil the climate. And we're investing very substantial amounts of money in developing and deploying the technology which can capture and store the carbon dioxide from the use of fossil fuels that continue. The other thing that we need to do is to invest in preparedness and resilience and adaptation to deal with the degree of climate change that we can no longer avoid. Climate change is already going on. We are already experiencing harm from climate change in many different ways that anybody who reads the newspapers or the news magazines or listens to Rachel Maddow on MSNBC already knows. And the way we sometimes phrase this is our dual challenge is avoiding the unmanageable by investing in mitigating climate change, reducing its pace and magnitude, and also managing the unavoidable. There is climate change going on. More is unavoidable. We need to manage it by being better prepared, and we are trying to do that as well. The last component is to cooperate internationally on all of this. That is, it is in our interest and the interest of the rest of the world to work together because we all live in one atmosphere under one climate, and we all benefit when any country makes investments in reducing its greenhouse gas emissions. We all benefit when any country reduces its dependence on oil in the security and vulnerability domain, and we all benefit when any country makes investments in increasing preparedness and resilience. So that's where we're going, that's where we need to go, and I think we can get there. Great.
So I get to talk about the living part of the environment, and the great thing about all of that is if you just give a species half a chance, it will make more of itself. In other words, thank God for sex. So if you think back to when the Tyler Prize was created, it was a time when suitcases didn't have wheels, when mainframe computers had the capacity that I now carry around in my pocket. And the phrase biological diversity didn't even exist, and certainly ecosystem services had not come forth as a sort of a formalized concept. And now that ladder is going forward quite rapidly in a lot of different ways, and part of the big trick here is how to recognize the value of what nature does in our formal economic decision making. But I thought it might be interesting just to focus on an ecosystem service that life on Earth furnishes that the vast majority of people are totally unaware of. And that is the way it helps this planet work as a biophysical system. And there is a big carbon cycle involving living organisms. And right at this time of the year, about 6 billion tons of carbon are coming out of the atmosphere because of springtime in the northern hemisphere and all the plants growing like crazy. Well, if you actually look at the excess CO2 in the atmosphere, a big portion of it has come from about 3 centuries and more of destruction and degradation of ecosystems. And it is perfectly possible, leaving plenty of room for agriculture for growing population, to do ecosystem restoration at a sufficient scale to take half a degree of inevitable, seemingly inevitable climate change back out of the equation. So when you wake up in the morning, be thankful that there are green plants and lots of other things. So.
I will talk about cities and urbanization. Why do we worry about cities? Well, about a century ago, roughly 10% of the world's population was living in cities. But nowadays, it's more than 50%, and the trend continues. Of course, in that same century, the world's population more than quadrupled, from about 1.6 billion people to more than 7 now. So cities are terribly important in terms of their impacts in the environment, contribution to CO2 emissions, and so on. But the worries, as we see with many of the Tyler Prize Awards, with cities is that they themselves have very large environmental problems. Of course, since the Middle Ages with sewage and so on, but more recently, air pollution, perhaps starting with the London smoke in 1952. The city was so dark you could hardly see. And the point is, one could document more than 4,000 people dying because of that air pollution problem. Of course, the reason was that people were using coal all over the place. But then later on, it was Los Angeles in the 1960s, and then Mexico City in the 1990s. It was so polluted that you could hardly breathe. In Los Angeles, airplanes could not land just visually. They had to use instruments. They couldn't quite see where to land, okay? And so it was just not agreeable at all to live there. I remember in Mexico City, diplomats just didn't want to go there, okay? It's awful. Well, fortunately, the point here is these problems could be solved. How were they solved? Well, government had to impose regulations, but this was in collaboration with civil society, also with the private sector, technology and innovation. Of course, we all know cars need catalytic converters, and it was the transportation sector in Los Angeles and in Mexico that caused these air pollution problems. Of course, catalytic converters are expensive, and people just wouldn't put them voluntarily. But government action coupled with agreement with industry and so on essentially solved the problem. Of course, we have yet much to do. But this points to the fact that many of these environmental problems can be solved. And of course, this is just one aspect of what we call sustainability. We like to see now at large cities, cities in general, urbanization as an opportunity to improve the environment. And it's looking not just at air quality, but you have to look jointly at economic, environmental, and social issues. You want places where the quality of life is large, green cities with parks and so on. So there's a movement in that direction, and it's certainly working. Take congestion. If it takes you hours to get to work, the city cannot function efficiently. It's a large strain on the economy. So all that can be dealt with. You have to have very good public transportation and so on. It's a whole specialty, but fortunately things are moving in the right direction towards sustainability. There's another more recent development I'll just mention very briefly, which is that although we look at these environmental problems in cities as a local problem, perhaps regional, it turns out that some of the emissions are also very important for climate change. Of course, CO2, which is emitted to a very significant extent in cities, is the global issue. But if you take some of the other emissions, for example, soot, the small particles, they are the ones that are the main worry with public health because they get deep into your lungs. They induce mortality in vulnerable people, but they also affect lung development in children. That's something you certainly want to avoid. Well, soot turns out to be second to carbon dioxide as a driver for climate change. So fortunately, there is something called the Clean Air and Climate Change Coalition, where the United States, Canada, Mexico, Sweden, and several other countries agreed to really promote measures to reduce these air pollutants. And you can do that because you have existing regulations. You don't need a new international agreement for this. And that's why you can get a head start internationally to begin to deal with this problem. You have to be very careful. This doesn't mean you can do this instead of CO2. It's urgent to begin to deal with CO2 as well. But if you take the other half of the problem, I think we are on the right track. I'm optimistic that society will certainly deal with these issues as urgently as it's really needed. Thank you.
Many of you, and certainly a lot of you in this room, are veterans of some of the environmental fights that have been won, or at least in which progress was made. I wonder if previous fights over CFCs, or over the issue of acid rain, or the issue of the Cuyahoga River catching fire, or any of the other issues on which we know that a problem was evident, a political fight was had, a solution was agreed upon, and environmental progress was made. If any of those past fights, to any of you, feel like have lessons in terms of the current arguments that we're having about whether or not to take carbon seriously.
Well, I think there are certainly lessons there. If you take the case of acid rain, where emissions of sulfur dioxide from power plants were the principal culprit, that was addressed with a market-based system, basically a cap-and-trade system in which permits were issued that limited the amount of sulfur dioxide that could be emitted. And to make a long story short, that market-based system ended up reducing by more than tenfold the previously estimated cost of drastically cutting those emissions and therefore drastically cutting acid rain. And what that says is the economic marketplace can be our friend if we find ways to price the pollution, to make people pay as part of the goods and services they buy for the economic damage and the environmental damage that is being done.
In terms of that initial fight and the squawking against it, the side that lost, did all those people end up poor and miserable? What's the short-term cost, presumably? It has to be measured against the long-term cost.
No, the interesting thing is nobody ended up poor and miserable. The costs of compliance proved to be very modest, again, far less than predicted. And the other thing is when you have regulations that people have to make investments to comply with, that too is a job creator. You know, environmental controls, improving the environment through pollution controls of various kinds, is an industry that's worth now more than $200 billion a year in the United States. A lot of jobs associated with that, a lot of income. I mean, the idea that money spent to improve the environment disappears into a black hole is just wrong. It's just a decision about how society is going to allocate its resources. And when you allocate them to improve the environment, you create jobs and economic well-being in that dimension.
In terms of the stakeholders in these fights, one of the things that is a thread among all of your comments is this idea that the larger the entity making the change, the more suppression there is of competitive disadvantage for people under that umbrella for complying with the need for change. So, for example, if one city decides that they're going to put some sort of restriction on emissions, you may lose businesses going to other cities who do not want to deal with those emissions. If the state does it, you're only going to deal with, the only problem may be people leaving the state. If the country does it, are those companies going to flee the country? Less likely. And as the institutions making the changes get larger, competitive disadvantage becomes less of an issue. In the United States right now, there's a part of our political system that's super freaked out about the idea of international agreements of any kind. The state of Kansas, this year, a legislator introduced a bill that would have banned the idea of sustainability from being considered in any Kansas law. Because sustainability itself is from the UN and therefore suspect. And Kansas is not interested. It didn't pass, but it did come up. Taking into account that paranoia about international agreements, what's our best hope for the most powerful stakeholders who can drive the largest and most effective decisions?
So I think there's an enormous role here for the corporate world. They're not going to solve the entire problem, but 70% of the jobs and 70% of the economic product of the world is corporate. And we're seeing a lot of movement in large multinational corporations, Unilever, a whole series of them, really wanting to look at environmental balance sheets as well as their financial balance sheets, and making pledges to do things like get deforestation out of their supply chains by 2020.
Why do they want to do it?
Because I think their leadership can see down the road that if the corporate world isn't part of solving this, they are going to get really squeezed, and their social license to operate will be questioned.
Dr. Ali, you, alongside your core scientific work, have made a real effort to be a public communicator on this issue. And when you talk about the history of climate change and what that foretells about our future, who do you, when you are explaining that to people, what is the most politically potent audience that you think you are reaching? Or what are the message magnifiers, people who are stakeholders, that you feel like may be most effective in communicating this to people who don't already believe it?
Yeah, I mean, ultimately, this is so bound up with our future, and there's so much opportunity here. You know, looking at the new ways forward and putting the scholarship into our planning is ways to make the economy better. It's ways to make more jobs. Your question to Dr. Molina, you know, if you think, and I'm not going to advocate a particular position, be very clear, but if you think for a minute, what do? We tax tobacco. And we do that to raise money for the government and to reduce smoking. And we tax alcohol. And we do that to raise money for the government and to reduce drinking. And we tax your paycheck. And we do that to raise money for the government. And reduce working. And you know the numbers. If I go to a student and say, give me a hand, I'll give you $10, they say, sure. And I say, I'll give you $5 and I'll give you the government $5. And they say, well, maybe not. And so there are thinkers, really serious thinkers, who have said, suppose that we taxed carbon and we reduced the tax on your wages. What would that do to the size of the economy? And in fact, there is serious scholarship that says, oh, the economy grows faster. Not slower, faster. right? And then at some point, there might be a little tweaking to international agreements, but suppose a reasonable fraction of the world said that they were going to do this. And is it conceivable that you could think of a world someday in the future where they could then say to other countries, you can tax your carbon and use the money for anything you want, except making carbon. Or we'll tax everything that you trade, and we'll use the money. What would you like?
Dr. Holdren, do you want to speak to that?
Well, I will speak to your earlier question of what works with different kinds of audiences. One of the things I've found that works, a lot of people say, well, global warming, what's the matter with that? A little warming's not bad for you, only be a couple of degrees. And what I say to folks is that the global average surface temperature of the Earth is just an index. It's a proxy for the state of the climate system, just as your body temperature is an index of the state of your body system. And if your body temperature goes up 2 degrees C, it's telling you something is going wrong with the state of the system. And similarly, associated with increases in the Earth's temperature of 1 degree C or 2 degrees C are enormous changes in the system, in patterns of rainfall, extreme storms, droughts, wildfires, heat waves, just a few degrees on the average, but that is an index that is telling us the whole system is going nuts. And that works with people. They get that.
The issue of whether or not extreme weather should be connected in the public mind to the broader issue of climate change is oddly contested by everybody who's not a scientist. In the news business, I can tell you, you get a lot of pushback against the idea if we're covering forest fires or we're covering hurricanes or we're covering some other unusual or unusually extreme weather system to not jump to saying this is related to larger patterns of climate change. Should we not have that seatbelt on? Should we feel free to talk about extreme weather and climate change as being directly connected?
Yes, I think even the scientific community was very conservative as recently as a few years ago because the claim was, oh, we don't have enough statistics to really connect the two things. But things have changed. And what you have to do is to ask the right question, not whether a particular drought was caused by climate change, but what is very clear from physics, from understanding the climate, if it has more energy, you expect the extremes to be more extreme, to put it that way. And so it's very clear you can do statistics with heat waves. There's no doubt that they're much more likely nowadays than they were before, and this is just with measurements from satellites. But the physics also tells you that all these recent studies, you can only talk about probabilities, but it's much more likely that all these events that are clearly happening more often than they used to happen, it's very likely that they are indeed connected with climate change. There are a few exceptions. There was a flood in Thailand that caused a lot of damage, and that's because many people moved to the wrong place or so. So it was not unusual amount of rain. But barring those exceptions, in general, it's very well established, the drought in Texas and the forest fires and so on, that there is a strong connection with climate change, but it is statistical. And by the way, this is very important because this can change people's sort of attitude towards climate change, and consequently, politicians as well. And clearly, you can then show that it's much more expensive not to deal with the problem than to take the necessary measures that we're all agreeing they're not all that expensive.
I will say, seeing the impact of extreme weather on municipal governments, talking about Hurricane Sandy or talking about other incidents in the United States that I have been just covering here, seeing municipal governments and state governments realize that they need to change policy, not because they want to do anything about stopping climate change, but because they need to stop people from building so far out into the water, for example, or they need to change floodplains, or they need to change whatever it's going to be that's going to allow them to have a better hope of surviving more extreme weather in the future. That seems to me like that, once that trickles up, as those politicians graduate to higher level jobs and move to Washington and these things, I think that's going to be a real slap in the face. I'm not sure how that's going to work, if that's going to lead to a new a new sort of rash of climate denialism. But Dr. Lovejoy, in talking about protecting ecosystems and in terms of making space even within our current development patterns for ecosystems to survive and do the work they need to do. Can you talk a little bit about the New York City watershed example, both its economic and the political way that that unspooled?
Yes, I mean, it's a really fascinating story, which has been repeated in other cities around the world. But when I would come home from college and have a glass of water at my parents' place in Manhattan, I would, wow, this tastes good. And it would win against fancy things like Evian water and blind tastings. It was so good. But over the years since I was coming home from college, the watershed itself was deteriorating. And finally, the EPA was going to require the construction of an expensive, maybe $8 billion water treatment plant. And the head of Region 2 for EPA, Konstantin Sidimon-Aristov, bought the idea that it actually would be a better solution simply to restore the watershed. That would be a permanent fix. It would cost less to run, and just let the biodiversity do what it had done before. And that came out at about 10% of the cost of the water treatment plant.
And how did they restore the watershed?
Basically, there was a bond issue, and they bought up some development rights on certain farms and let the natural vegetation, forested vegetation, come back.
That's cheap.
Yep, and permanent, and
Yeah.
permanent.
I'm going to go to questions now from the magic of the internet machine that are being delivered to here from the audience, both online and in the room. As Dr. Molina said, or as it says here, as Mario said, which I would never say, urbanization is rapidly on the rise, especially in the developing world. You talked about air quality, but what about animal to human disease and other problems? What are the implications for the environment and public health in particular of rising urbanization?
Well, I'm not very acquainted specifically with animal to human disease transmission and whether that's something that is worse in the cities, say, than in farms and so on. But in general, the public health issue in cities, of course, is very important, but it's very well studied. And so you have an opportunity actually to do better with that, to treat people and so on and so forth. But in general, I think if you look at it in a broader context of economic development, okay, you can decrease the number of very poor people. Of course, you have problems in developing countries, very poor people in cities as well. But you have an opportunity to do better with that as well, to increase quality of life, health services, and so on. And so that's something that if you pay attention to it, you actually have an advantage in cities because you have everybody together. But you do have to worry about it, and it's indeed a very big problem in many large cities of the developing world. We have a big task there. But the point is we have several success stories. We just have to copy those.
Are cities willing to see other cities as pilot programs for good environmental practices? Or is there chauvinism between cities?
Yes, no, there are actually some collaborations between cities. One, for example, is dealing with climate change. There is some sort of joint venture between more than 100 cities. The mayors of these cities agreed to work together, do something about climate change, but not just in paper. They're going to measure emissions, and they're going to compare what works and what doesn't work, public policies and so on. So I think it's the other way around. Cities are very willing to learn, or at least most of them, okay, from what works in other cities.
I think city government is the future of technocracy in the United States, but we shall see. From the audience, given the increasing urgency for action, how do the environmental and agricultural communities come together to find common ground on sustainability? I.e., how do we balance the need to feed the world with the fact that agriculture contributes so much to carbon emissions? Dr. Ali, do you want to jump in?
Yeah, I'd start. We should be listening to Diana Wall over here. Okay, another talk. But I mean, ultimately, we have to look at the big issues of sustainability. And there's no question about that. And if you look at sustainability, the UN has identified energy and food as the two biggest places that we face challenges. And of those two, some of the food issues are linked to energy. So in some bizarre sense, getting energy in control is probably the single most important thing to do on this. That having been said, preserving the soil, enriching the soil, preserving the farmlands, Dr. Wall gave us a fascinating talk yesterday and was pointing out how little of the world feeds how many of us, and how little of the world is suited to feed how many of us. That keeping this in play, keeping it well developed. After that, you know, I think my doctor would be happier if I ate a little bit less meat. There are ways that are win-wins in this, that you clearly can bring the environmental and the agricultural communities together because they ultimately want the same thing.
Do you share that view, Dr. Lovejoy? You talk a lot about land use and distribution of land.
Oh, absolutely. So agricultural systems have to, in general, become ones that don't leak carbon, but instead sequester and build up carbon in the soil. And what do you get when you do that? You get greater soil fertility, right? I mean, that's what the composting game is all about in a way. And there's some real world, you know, long-going experiments showing that you can actually make these things work. And the other big piece of it, of course, is the use of nitrogen and fertilizer. And we simply have to find ways to leak less nitrogen into the environment. It's a whole other story, but it's really important because it's affecting the productivity of waters. Right?
If I could make a little plug here. Yeah. The President's Council of Advisors on Science and Technology, PCAST, of which Mario is a member, and some other folks in the room are members as well, issued a report last year on the challenges facing agriculture and what we can do about them, including the kinds of research in the agricultural domain that will enable us to feed more people while still dealing with the challenges, in particular of climate change, of water availability, of heat stress, and so on. And that report has been very well received at the USDA and is now helping shape their research strategy going forward. And it can be found on the web, like all of the PCAST reports, at www.ostp.gov.
On the issue of fertilizer and nitrogen and runoff, is that something that's going to take more of a 180-degree turn than a 30-degree turn? Is fixing that going to require a bigger change than some of the other issues that we are talking about?
Well, you know, there's generally speaking an excessive use of fertilizer.
Yeah.
And so, again, if you get the price right, it'll be used more judiciously. And then there are all these plants that are naturally nitrogen fixers. And so crop rotation is one way that you can actually enrich the soil with nitrogen without even use of fertilizer. So there's a lot of potential to go in the right direction.
Can I be an utter Luddite for a moment and ask you to explain something that everybody in this room gets, but I don't? The idea of capturing carbon and storing it somewhere sounds to me like in science fiction, the way, or in sort of magical realism fiction, the way this would go would be like, oh look, we solved the ladybug problem because we brought in frogs, and then it turns out we had this python problem, and now we've got, like, it sounds to me like a bad idea, and I'm sure it isn't because you're suggesting it, but I don't get it.
Carbon dioxide in underground formations, which can hold a lot of it without leaking, is much better for all of us than carbon dioxide in the atmosphere. And the technologies already exist for capturing carbon dioxide from fossil fuel use. And the technologies exist for piping it around and injecting it into the ground. In fact, we do quite a lot of that today in the domain of enhanced oil recovery. That is, by injecting carbon dioxide into oil formations, more oil comes out, and most of the carbon dioxide stays down there. Of course, like every other technical fix, you're right to ask, what will be the side effects? What will be the dangers? Can we deal with them? A lot of smart folks are in fact looking at this. It is already clear that there are some better places to store carbon dioxide underground and some worse places. I hope and trust we'll be smart enough to pick the good ones.
What I'm worried about, I think, is because I am extrapolating from that idea, or at least jumping from that idea, to the idea of wastewater injection from fracking and other things. And it seems to me like the reason that I'm nervous about the solution being injecting something into the ground is that it seems like there is very little regulation in general about things that we inject into the ground. We are willing to put stuff there and forget it, as if it's the gates of hell, but in fact, it's the thing that we walk on every day. And I'm just worried that we're not protective and therefore maybe not careful in terms of approving new technologies for burying stuff.
Well, we do need to be careful, but I would point out that what you get when you inject carbon dioxide into water is carbonated water, which is relatively innocuous stuff compared to the things we should worry more about injecting into the ground.
Has everybody been following the news about the weird earthquakes in places that didn't used to have earthquakes? That's what I'm freaking out about, just so you know. Question. With all the benefits of hydrogen energy technologies, the benefits that they afford to society, storage for renewable energy, non-pollution, et cetera, why don't we hear more about hydrogen energy technologies and their application in achieving highly efficient systems?
Well, the answer to that is that as attractive as hydrogen is for the purposes that the questioner mentions, there are still some major technical hurdles that have to be surmounted before widespread use of hydrogen can be made economic. One of those hurdles is how to store it economically. Hydrogen has some very intractable characteristics, like it diffuses readily through stainless steel. So you need to be very careful in developing containers. Its energy density as a gas is very low, so you need to compress it to very high pressures if you're going to use it, for example, as fuel for your automobile. The fuel cells that are the most efficient way to use hydrogen and are extremely attractive in principle are extremely expensive in practice. They remain many times too expensive to use on a massive basis in automobiles. All these challenges are worth working on. In principle, they can be overcome. And the federal government and the private sector are working together on solving those technical challenges. So I think the questioner can expect to hear more about hydrogen going forward.
Okay. Dr. Molina, what would be the most effective strategies for protecting children's environmental health in relationship to today's discussions? You just spoke about that a little bit in terms of soot and children's lung development, but are there broader ways that we should be thinking about children's health being protected right now?
Yes, of course. Air quality is what I mentioned because that's an obvious thing to do, but there are many other aspects of children's health that need to be considered. We talk about poverty. Poor people, of course, they don't have often even enough food to be healthy. And yet we have the opposite problem in large cities. Mexico is even having a program against obesity. So you have all sorts of issues that are related to the way children are brought up. I think a very important component of this is education, of course. You have to educate families so that they have healthy habits. But yes, there are very large opportunities there to improve children's health.
Dr. Lovejoy, how's the Amazon?
So I would characterize the Amazon as in a race to the finish with some extraordinary achievements. So since I first set foot in it, it has now gone to something more than 50% under some form of protection, a little-known success story.
How did that happen?
It was growing awareness. It was having the Earth Summit in Brazil. So for weeks after week after week, environment dominated the news. a change in sort of the political leadership in the Amazon governors, global financial assistance, contributions by science. But it's not all rosy, because the deforestation is now pushing close to about 20%, which doesn't sound like an ominous number. But when you understand that the Amazon, in fact, makes sort of half of its own rainfall, at a certain point you can undercut that hydrological cycle. And the few models that have been run that touch on that suggest it is around 20%. So the good news here is the Brazilian government is actually quite interested in doing some active reforestation, sort of build back that margin of safety. So the biggest problem that remains is a lack of integrated planning, which seems to be something that humanity does generally, you know. But there's even some talk about trying to move in that direction.
What's driving the deforestation that continues?
So it's building roads, all kinds of things follow roads that once they're there that nobody envisioned beforehand, and big commodity markets for soybeans and beef, and those are the primary land use changers in the Amazon.
Dr. Alley, we hear repeatedly that what the United States does with regard to climate change is irrelevant if India and China do not also act. Please comment.
Yeah. Ultimately, it's global. The atmosphere is not remembering who put the CO2 up. But it's a little bit hard to imagine the world moving forward seriously with a very, very large chunk of the economy not involved. It's a little bit hard to imagine a lot of people who were in this town 50 years ago saying, or 60, 70 years ago saying, oh, you know, we can't rebuild Europe. US can't lead anybody anywhere. We're just powerless against this giant world out there, aren't we? And when I was taking history, I never, ever remember hearing those words in my history classes in Ohio, that we in the United States are powerless to do anything about leading the world, because, hey, it's a big world.
Can I add something on that again? I think it is very important to recognize that in both China and India, China now being the world's largest emitter of carbon dioxide, the United States is second, India is fourth, moving rapidly toward being third. In both of those enormous, more than billion citizen developing countries, the leadership is fully aware of the damage already being done to their countries by climate change, and they are fully aware that ultimately the problem cannot be solved without their participation. And if you doubt that in the case of China, you should go onto the State Department website and read the joint statement that was issued on April 13th when Secretary of State John Kerry was in China meeting with the Chinese leadership, including the president. And China and the United States have now committed to drastically ramp up their cooperation addressing climate change. And the statement describes exactly how we intend to go about it. And my view is that when the United States and China start working more seriously together on climate change, with great clarity as expressed in that statement on why it is essential to do it, a lot of the world is going to follow.
Is China building new coal plants, and do they see coal as their short-term energy future?
China is building new coal plants. They're also building new nuclear plants. They're also building wind farms and solar generating sites. They are using the most advanced coal technology currently available in the world for their new plants, which make them lower emission than older plants. But they will ultimately need to go to, forgive me, CO2 capture and storage. For those coal-burning power plants, or the contributions that they're going to make to ongoing climate change are going to be unbelievably large. But they understand that. That is, the good news is, and I've spoken to many Chinese leaders myself, they get it. They are already suffering in China from effects of global climate change on the East Asia monsoon, which are aggravating historical problems of flooding in the south and drought in the north, impacting their agricultural production. They know they've got a problem. They know it can't be fixed without them. And so this notion that what the United States does doesn't matter because nobody else is going to do anything, this is just profoundly wrong. Most of the countries in the world recognize at the level of their top leadership that climate change is already doing damage and it will do more until we work together to stop it.
Dr. Molina, looking at increased urbanization in China and India and these places, how do you see it?
Well, urbanization is something that China is certainly dealing with. They have a big air pollution problem, but I wanted to add to the other conversation as well, because the perception internationally, it's not that the problem is mainly China and India, and it's certainly not that it's President Obama's will to deal with it, but it's US Congress. And that's because of denial of very fundamental science. So we hope we, the scientific community, can do a better job communicating the fact that there is essentially a consensus about climate change science, as opposed to this misunderstanding that some say it's this way, some say it's this way. Not the experts. They certainly agree.
Did the scientific community do something wrong, or in retrospect, could you do something differently to avoid that misunderstanding?
Oh, yes, yes. We have to learn to communicate much better, and of course to counteract this very well-organized plan to discredit the science that was extremely successful, of course, from interest groups, which is very well documented. We were very slow in responding, and so we have to do something to respond to that.
That side thinks they won.
Sorry?
The other side, the well-organized denialist side, thinks they've won the argument, and they think they have permanently seeded the American public with the idea that science in this field, and actually science more broadly, should always be suspect and should always be seen through an ideological lens, that science is inherently left-wing. And I say that they believe they won just because they plan on keeping on and expanding their efforts because they are so pleased with how it's gone thus far.
But they're not reading the polls. What the polls show is that they have not won. What the polls show, depending on how you ask the question, is that between 65 and 75% of the American public believe climate change is real, substantially caused by human activities, already causing harm, and needs to be fixed. And that is an extraordinary percentage of the American public to believe anything.
And science works, right? Here I am sitting, you've got one, right? It's got a GPS in it. If I turned it on, it would know where I am. The first time I met that GPS, it was being used to survey motion in Antarctica of ice streams. And to figure out where you were, you had to bring the data home and work with them for a long time because the Air Force was dithering it because it was a military secret where you were. It's a military thing in there, but it's science that's in there.
Yeah.
You know, and everyone knows this. Everyone knows this, that you can't, the bridge club or the tennis team cannot turn a handful of red rocks and a handful of blue rocks and a cup of oil into this, okay? It still works.
You're going to get picketed by bridge clubs.
Sorry.
Did you want to respond to that at all? Did you want to get in on that discussion?
Well, I think actually your point is the most important one. The American people are using the products of science every day, right? And why should they pick particular ones to disbelieve, right? If they really thought it through.
It is one of the things that that's going on in political science right now, lived political science, is the number of important issues, particularly long-term horizon issues, on which the argument has been won. And the public polling shows that the argument has been won, but the political fight has been lost.
Yeah. Yeah.
And we saw an example of that. However you feel about the issue of gun reform, yesterday seeing something that has 90% support in the American public not be able to pass filibuster threshold in the US Senate, which is Democratic controlled. Usually in societies where that happens, it's easier to identify in other societies rather than in their own, but usually in political science terms when that happens, there is a great realignment in democratic systems, or democracy itself gets strained. I don't know if that's where we're headed, but climate change seems to be part of that. You have mentioned nuclear energy several times. I know that your scientific work includes a lot of time spent on the issue of proliferation and the nuclear weapons side of the nuclear cycle. Is nuclear energy environmentally friendly? Even though it doesn't produce CO2, it produces large amounts of radioactive materials. And I would add to that the proliferation concern.
Right. You know, one of the first lessons one learns in looking at the array of energy supply options is that there is no such thing as a free lunch. Every energy option has liabilities, and the approach that we need to take is to see if we can, by good management and good technology, make those liabilities small enough that it makes sense to use a particular option and to expand it. Nuclear energy basically has four challenges. One is economic. Today, nuclear energy cannot come close to competing with electricity generation with natural gas. And the second one is nuclear waste. We still have not embraced a national strategy for nuclear waste management which will meet the expectations of the public or even the expectations of the electric utility industry. We have to do that. We're working on it. The third one is proliferation of nuclear weapons. And there it is unquestionably technically possible to advance and expand nuclear energy going forward in a way that does not contribute to proliferation, but it's also possible to do it wrong. We could screw it up. The only answer there is if we're going to do nuclear energy, we better do it right. And the fourth, of course, is safety, as underlined by the Fukushima events, which, of course, were stimulated by an enormous earthquake and a tsunami. But the fact is, already as a result of Fukushima, we have learned many lessons about how to protect nuclear power plants better against extreme natural events. But we will not see an expansion of nuclear energy, as useful as that would be as a contribution to reducing our greenhouse gas emissions, unless and until all four of those obstacles are addressed to the satisfaction of the public.
On the first one, which is cost, the reason it's so expensive is because fission is an expensive way to boil water, right? But it's really about building a plant and building a plant.
It's the construction.
It's the construction costs,
right.
And that is something that you have to do with incredible attention to safety. Do you think that it is more expensive to build a plant in the real world right now than it should be?
Yes. Besides that general answer, there are advanced concepts out there like small modular nuclear reactors, which could be basically built on what amounts to an assembly line, which would drastically reduce production costs. And at the same time, because of the characteristics of small versus larger reactors, would be safer. Again, I think there are interesting possibilities there, but I'm not holding my breath because of this whole series of challenges that need to be addressed. And by the way, the competition, economic competition between nuclear energy and fossil fuels, or between renewables and fossil fuels, would be made much fairer. The gap would be shrunk if we put a price on the emissions of carbon dioxide, which are imperiling our climate.
Do you think that's going to happen? I'm not asking about policy. Do you think? I'm not asking about what the White House is going to do, but do you envision?
Thank you for not asking.
Thank you. I understand how this works. But I mean, we did, as you talked about acid rain, we put a price on that. And so that became something that we manipulated the market so that the market would produce an outcome that produced 95% less acid rain. Is that the way that carbon is going to be ultimately solved as an American problem?
I believe that ultimately carbon dioxide emissions will be priced as a societal decision basically around the world. But obviously the question of when ultimately is a highly political question, and I don't have a clear crystal ball.
Let me just mention very briefly that it's already taxed. There is already a price on emissions in Australia, for example, in some European countries. Even India has some tax on coal-fired power plants. So it doesn't seem to be entirely out of the question, but of course we still have a long way to go.
So I think the political opportunity will
be when there is tax reform. You know, we lower people's income taxes, payroll taxes, and substitute it by taxing carbon.
I have one question which is not particularly a science question, but I realize nags at me when when we talk about the prospect of progress on these matters. My girlfriend is a photographer, and she did a series, she does sort of abstract photography, and you can't always tell what she's taking pictures of because it's always very blurry. But she did this sort of, did a series of industrial landscapes where she went to Port Sulphur down in the Houston, Louisiana area, and did the whole oil refinery area there. And then she did a long series of photos in Camden, New Jersey, which I think of as recycling town in an ironic and bad way, because there are rules about throwing away things like computer monitors and stuff in New York City and in other urban environments and suburban environments. And for whatever reason, and I don't think it's legal, a lot of that stuff that gets recycled, what happens is it gets dumped in lots in places like Camden, New Jersey, in poor parts of the country that are neglected, that will someday in the future be brownfield sites, but right now are open septic pits where people live. And there are very poor parts of even our country, even on the eastern seaboard, and they are already bearing the unintended consequences of some of our efforts already to do right by the environment. And poor communities are already really suffering. Is there some way, as we try to force more progress, to guarantee basic standards of environmental justice for the people with the least political capital in our country? Will Richmond, California, ever have less kids with asthma?
That is a great question.
We can leave it at a question if you'd like.
I like to think that we will eventually get that right. But you phrased it perfectly. The people who have the least economic and political power end up with the largest part of many different kinds of environmental burdens: toxic substances, air pollution, soil pollution, and more. And one of the reasons that a degree of regulation and oversight by government of private practices is required in the interests of society is to protect our most vulnerable members.
So if I could just comment on that in a different dimension, namely time looking into the future. You know, it's the next generations who are going to suffer a lot of these things if we don't do better than we're doing, and it's because they don't have a voice. So there's great new movement, you know, grandmothers and mothers looking ahead to the future generations who are getting involved on climate change, for example. So that's a real matter of hope.
I am not a member of this panel. I'm supposed to be moderating, but I'm going to take personal privilege because I have a microphone on to just say, like, I have one idea around this. So the best thing on television in our era is not, obviously, cable news. It's reality television. And we think of that as sort of Snooki and Jersey Shore and all this stuff. But the best reality television is like the cop shows and stuff, where it's not CSI actors portraying cops with gore. It's actual law enforcement out there in the world, and there's somebody with a shaky camera following them around. There's a few reality TV shows now which are essentially environmental cop shows, where they follow around the police, the type of police who stop you from poaching. And so they're out on the stakeout, looking at these guys who are in a fishing camp who they don't think have licenses. And it turns out they're killing way too many trout. Look, we found all the trout heads. We're gonna lock these guys up. And you're watching this thing and you're half-baked and eating Cheetos or whatever, but you are rooting against those environmental criminals who are killing those animals who don't need to be killed. And look at the way they're treating those carcasses of those deer and you end up rooting for the environment because you've got these badass, burly, tattooed cops going after them in a way that gives the sort of environmental impulse a more marketable cast than y'all. So I don't mean to be insulting, but there's something to build on there. And they're doing, I think the natural human empathy with animals is giving them the place to start where they're going after poaching, but looking at environmental crime and looking at it as, and looking at the interest of environmental cops, stopping people who are dumping stuff, stopping people who are evading whatever future market-based controls we may have on carbon and these things. There is a muscular, consumer-friendly angle to put on that somebody smarter than I will do. We have time for one more question. And it is a little bit out of left field. It is about the United States military. The US military is the largest organization in the world. The US military is the largest user of fuel in the world. And in this administration, a number of, it's also the largest user of discretionary income in the budget by a mile. In this administration, a lot of funding for innovation and practical application of innovation in energy technology has gone through the Pentagon. Dr. Ali, you were talking about the military as stakeholders that can be particularly compelling in this issue for the general public. Could you explain what you meant by that?
Yeah, so I mean, let's be honest. First of all, I've got my cell phone still in here, still turned off. The GPS is a military program. It is connected to the internet. Now, some of you are gray enough, as I am, that you know the first time I logged on to the internet, it was the ARPANET. It was the Defense Advanced Research Projects Agency. They wanted their researchers to talk to each other, and they built the bad blame World Wide Web eventually. And I drove down here, my dear wife and I drove down here on a defense project, right? It's called the interstate system. But we have relied on them to do things for us, both in national security and in the things that spin from national security into the real world. And so many of the good things we have, right back to Lincoln building telegraphs so he could run the Civil War, have come out of those joint efforts that have involved the military. They, in addition, command a lot of respect in quarters where I may not. And we had this wonderful, wonderful experience. I got to make some PBS TV with Jeff Ainstyle and Ergun Kugano, who are right over there, a little advertisement, or the operator's manual. And at the point where I could say this is going to be a problem, there is an admiral in dress white saying this is a problem. And when they took this and ran it to focus groups, people who were predisposed to not believe me have real difficulty not believing the Rear Admiral in his dress whites. And the Rear Admiral was very good, Rear Admiral David Titley in this case. And it's real for the military. They have to deal with reality. And when something breaks, we ask them to fix it. And daggone it, they know what breaks things. And so in terms of them knowing, and in terms of them being an organization that has the wherewithal to make a difference, we have a lot of talent, a lot of skill, a lot of dedicated people in the military that actually can make a difference.
The most recent, so go ahead.
I was going to say, I mean, the military is certainly pioneering in areas like drop-in biofuels, where drop-in means you can just put it in the fuel tank you've already got and burn it as if it were the commercial petroleum-based stuff. And the military has now flown naval fighters at greater than the speed of sound, running on biofuel. They have plans to fuel a very substantial fraction of the fleet on biofuel. They are fans of renewable energy, in part because it can often shorten supply lines that have to be defended and that cause casualties in defending the supply lines. You make them shorter by using renewable energy sources. You save the lives of American troops. The military understands this very well. And just in the last year or two, the Pentagon has put out 2 or 3 reports on how and why climate change is going to be an enormous challenge for the military and why it's in the interests of the nation to work to abate the pace and magnitude of climate change, because the military's jobs are going to be bigger and harder under climate change than they already are.
And they also support the law of the sea. Right? You know, it puts the rules out there instead of it being sort of up for grabs.
The integrity of the oceans end up being a
part of it.
I think the thing that has emerged here for me today is the idea of unexpected stakeholders and unexpected leadership, and the kinds of credibility that can come from immediate practical need. And so the cities trying to protect the length of its commutes and the health of its kids, and corporations having horizons that may be longer than individual governments. Corporations having horizons in terms of what's coming up for them as a competitor with their own industry, but also as an organization that intends to be around longer than the lives of its own board of directors. The military as a great user of energy, and as you say, the people who we call on to fix stuff, people who have a lot of credibility on predicting what's broken and what it will take to fix it, and the other countries of the world that we look down our noses at in terms of how respectful they are going to be when they're going through the sorts of development processes that we may have gone through before, but they're going through them now with even larger populations. Their leadership being far-sighted and being willing to work with us, and in some cases to lead us when we expect that we would be leading them. All of this is about leadership and stakeholders emerging from places that we stereotypically wouldn't expect it. And the unexpected is usually the most powerful force in any dialectic. So this is fascinating. I just want to thank you all for having done this, and thank you all for being so kind to be here.
Thank you. Thank you. Thank you. You were great.
Thank you, panel, for providing us with a means to sharpen our focus on what we may be expecting regarding the quality of our environment in the near and in the distant future. We appreciate your coming and doing this, and we thank you, Dr. Maddow, for your fine leadership and provoking good thoughts and discussions with this group.
There's a Quaalude under each of your seats.
One other item. This week, our nation has experienced two serious blows, Boston and yesterday, Central Texas. Thinking about what we've lost in terms of our lives, of our colleagues and friends across this country, let's just take a moment of silence and think about these folks. We thank each of you for coming, and we hope you'll have an excellent remainder of the day and continue thinking about what we've learned today.